The lower fixed point of this thermometer is a triple point of water, which 273 K. The upper fixed point is the temperature of steam at 1 atmospheric pressure. This temperature is marked as 373 K. The interval between these points is divided into 100 equal parts. Each part measures 1 K, 1 Kelvin, not 1 degree Kelvin. An interval of 1 degree is equal to the interval of 1 K. The zero of this scale marked 0K starts from 273 degrees centigrade. This is the lowest temperature ever reached. This is the reason why this temperature is called absolute zero, and the scale of temperature is also called absolute temperature scale or absolute scale of temperature. From the above table it is clear that any temperature degree measured in Celsius scale can be converted into Kelvin scale according to the relation. This thermometer is used by doctors to find the temperature of patient. It is also found nearly in every house and is used to know the temperature of an ailing member of the family. It is modified from of an ordinary mercury thermometer, since the normal temperature of healthy person is about 37 degrees centigrade or 98 degree Fahrenheit. It has a short range of temperature from 35 to 43 or 95 to 110 Fahrenheit. This thermometer has a constriction in its capillary tube just above the bulb. On putting the bulb of the thermometer into the patient's mouth, the temperature rises, the mercury in the bulb expands and passes through the constriction into the capillary tube. On cooling, the mercury in the bulb contracts, but the mercury in the tubes does not fall back to the bulb because the constriction prevents it from doing so. Thus, the temperature of the patient as shown by the thermometer can be read at leisure. In order to take fresh reading the temperature of a patient by the thermometer, the mercury thread is shaken back to the bulb. The lower fixed point on this scale is the triple point of water or melting point of ice at 1 atmospheric pressure, which is marked as 32 degree Fahrenheit. The upper fixed point is the temperature of steam or boiling point of water at 1 atmospheric pressure. This temperature is marked as 212 Fahrenheit. The interval between these points is divided into 180 equal parts. Each part measures 1 degree Fahrenheit. Almost all material bodies, whether solid, liquid or gas, expand on heating. This expansion is called thermal expansion. A metallic lid tightly fixed on a jar is loosened by running hot water over it. As the temperature of the lid increases, it expands more than the portion of the jar under the lid, and hence loosening takes place. If a hole is made in a metal plate and then heated, the size of the hole increases because of its expansion. The inner edge of the plate forming the hole is metallic and hence expands on heating. This result in the increasing of the size of the hole, as clear from the take a metallic ball which just passes through a ring, the ball is heated through a relatively long range of temperature. The ball is again tried to pass, but no use. This shows that the ball has expanded on heating. It is clear from all the above examples that expansion takes place with the increase of temperature. This is the reason why allowance is made for the expansion of solids as a safety measure in certain situations. A gap is left between the adjacent rails of a railway track. Space is left between the beam and the wall of building to allow the safe expansion of the beam during summer season when there is an increasing in the temperature. Special joints or supports are needed to allow expansion in the construction of decks of bridges. A completely filled, tightly capped bottle of water cracks on heating. It is because of the more expansion of water than glass bottle on heating. Temperatures are measured by liquid and gas thermometers using the property of thermal expansion of liquids. There are two types of expansion associated with a liquid. There are real expansion and apparent expansion. A real increase in the volume of a liquid that takes place due to increase of temperature is called real expansion. This expansion is independent of the expansion of the container. An apparent increase in the volume of a liquid that occurs due to a rise of temperature is called apparent expansion. It depends on the expansion of the container. When a liquid is taken in a container and heated, both the liquid and the container expand simultaneously. The difference of these expansion is called apparent expansion. If V and are the expansion in volume of the liquid and the container respectively on heating, then the apparent expansion denoted by V is given as. Here V is the real expansion of liquid. We can demonstrate these expansion experimentally. A flask fitted with a cork is filled with colored water. A narrow glass tube is passed through the hole made in the cork. Water is filled to a mark A made on the glass tube. The flask is then heated. The level of water is the glass tube first fall to a certain mark B because the expansion of the flask, which is heated first. When heat reaches gradually to water, the latter also expand at a rate greater than the flask. The result is that the water level rises to a higher level marked at C as shown in the figure. The volume of a water in the tube from B to C gives the real expansion, whereas the volume of the water from A to C gives the apparent expansion of water. One-dimensional thermal expansion, that is expansion along the length of a long solid body on heating, is called linear thermal expansion. Consider a thin rod so that its expansion is nearly dimensional, that along its length be its original length before heating at temperature. The rod is heated temperature T so that its length increases B. The increasing is length when the rise in the temperature due to heating. It is found experimentally that the increase in length varies directly with the original length and also varies directly with the increase of temperature. That is where A is a constant and depends on the nature of the material of the rod. It is known as the coefficient of linear expansion. It is expansion numerically increase in length per unit length per degree rise in temperature. This means that if we take a rod of length 1 meter and heat it through 1 degree or 1 K, so that the increase in length is then the coefficient of linear expansion. The greater the value of A, the greater will be the rate expansion we can use.